In this video, we're going to take a look at some basic unit testing in the Python programming language. I'm going to be doing my demonstration using Visual Studio Code, and some of the things that I do will be specific to Visual Studio Code, but the overall idea will work in any IDE. I'll kind of point out some of that where I can. But Visual Studio Code does have some tooling built into it or actually added on as an extension that I like and that I'm going to encourage people to use. So whatever IDE you're using will probably have similar features, but I'm not familiar with those. So we're going to do Visual Studio Code. I am also choosing to use the unit test framework to set up our unit tests here. And it's probably not the most commonly used one. That would be PyTest. And both of them are very similar. PyTest has some more advanced features. It is the one that's most commonly used in industry. So it's the one in the long run that you'll probably use if you stick with Python. But I did pick this intentionally. First of all, they're very similar to each other, and anything you learn how to do in one will transition very easily over into the other one. But primarily, it's that unit test is included in the Python standard library. So it's already on your computer if you've installed and set up Python for development. PyTest is an external library that you'd have to kind of download and install. It's not difficult to do, and depending on your setup in Visual Studio Code, you may already have it installed. In fact, you probably do, but we're just covering this on a real fundamental level, so we don't need any advanced features, and I just wanted to eliminate that one variable of people having trouble importing the module or the library or whatever. So that's my reasoning there. This video does assume that you have a basic idea of what unit testing is, and if you have no idea what I'm talking about, you should probably stop here and go check out some of those other resources first. With all of that said, let's go ahead and jump into Visual Studio Code and get started. So this is the module that I'm developing that I need to be able to test, and the file is simplefunctions.py. As the name implies, it is about as simple as I could come up with. Right now it has one function. It's called thrice, which is kind of an old-fashioned word now, at least in the US. We don't use that anymore, but it means 3 times, right? In the same way that twice means 2 times. So this function takes a number and it multiplies that number times 3 and gives back the result. And the idea here, up until now, I've been testing it probably something like this, where I'm just going to call the method, give it a value, and output the results so I can see what's going on. So if I run this, giving it the number 4, it's going to return and then print out 12, right? 4 times 3 is 12. Easy enough. If I really wanted to go crazy, I could automate this a little bit and maybe run a handful of tests. So I could write a loop that just calls it on a whole range of numbers, so from 0 to 15 in this case. If I run that, it's just going to multiply each one of those times 3. I can kind of scan through that and check that everything is working as it is intended. This is a real kind of fundamental way of testing. It's the way we all start out testing when we begin writing code, and it serves us well when we are beginners, because when you're a beginner, almost by definition, your code is not very complicated, right? And so this type of testing is sufficient. But as our code begins to get more complicated, and as we have a bunch of different functions all kind of interacting with each other, what we want is a way to make sure that not just test as we're developing it and make sure it works all right now, but as our project expands and grows, we want to make sure that we don't break any pre-existing code. So the idea with unit testing is that we're going to maintain a testing suite, a set of test cases that we can execute constantly throughout the life cycle of our development project. And that's where we're headed next. So this old-fashioned testing approach has served us well, but we're done with it for now. I can go ahead and delete that. I have created the file that I'm going to use for my my unit testing here. The naming convention is very standardized. It is the name of the file that we're going to test, but we're going to add the prefix test underscore. So since I have simple functions, this one is going to be called test underscore simple functions. Pretty basic. The first thing we're going to need to do is we're going to need to import our testing framework. And so the framework is just the library or the modules that are going to kind of implement the testing for us and help us manage that. And as I mentioned in the introduction, there are two that are commonly used. There's PyTest, which I believe is the more common one, and especially in industry. And then there's unittest, and as I mentioned, we're going to use unittest for the simple fact that A, they're very similar anyway, and B, this is part of the Python standard library. I don't have to go import anything or deal with any downloads or anything like that. So I'm going to start out just by importing that. The tests that I create are going to have access to simple functions as well. So I also need to import that, and you can check out other resources if you're not familiar with how to import stuff. A simple import statement like that will do it. Notice that now if I want to access my stuff, we know how these import statements work. I'm going to use the nerdy way of saying I have to fully qualify that function call, and by that I mean I have to say the name of the module dot the name of the name of the function. That's annoying to me, so I'm gonna use a from statement instead. So from simple functions import, and I'll just grab it all, and that allows me to reference those the members of that module just directly without any prefix. So that's going to call thrice, and we're not really doing that. I'm just making sure that my import statement worked correctly. And the way we're going to start this out is we have to create a class that's going to hold our test case here. So we're going to define a class, and the name here doesn't matter as much. I'm just going to call it test simple functions like that, just trying to be at least somewhat consistent. And the important part here is that we need to inherit from the test case class, which is in the unit test framework, the unit test module. So that's, I guess I didn't mention this at the start of the video. I guess I'm also assuming that you know at least a little bit about what a class is and how inheritance works. I do think if you don't have a solid grasp of that, you could probably still follow along with what I'm doing here. And within this test case that we've created, this test case class that we've created, I can now start defining all of my tests. And so for my approach, what I'm going to do is I'm just going to have a test for each function within my modules. That's a pretty standard way to do it. So again, I'm going to stick with that test underscore naming convention. So I'm going to test the thrice method. And since we are writing a class now and we're using inheritance and instance methods, that parameter is going to, for that argument there is going to be self. And the idea is now inside of this test method, what I'm going to do is I'm going to run a function, a method actually, that asserts whether I get the result that I want. And I'm using the word asserts intentionally here. What I'm going to do is I'm going to call self.assert equal. And you can see that there are a whole bunch of different options here. There are more than even are shown right there of these assertion methods, and I should spell it correctly, I guess. Assert equal, and you commonly might ask, well, what's the difference between equal and equals? That's equals with the s on the end is just kind of a legacy. It actually aliases, as far as I know, to the same method. So I guess there's not really a difference, but I believe that's a Python 2 convention, and since we're in Python 3, we should just use assert equal. And what we're going to pass in is basically two values that we want to compare. So on a real simple level, this would this would assert that 3 is equal to 4. 3 is not equal to 4, so that's going to return false, right? That test, that assertion is going to fail. If I were to assert that 4 is equal to 4, obviously that is true, so that is going to pass as an assertion. That is not a particularly helpful assertion in our case, but what I want to do is I want to call that thrice method. And I think the original one I did was I called thrice on and passed in the value 4. And if I give it 4, then what I expect in return is 12 as my result. So this is an assertion. All right. So far, so good. I'm going to save it, and that will format the document for me as well there. Let's go ahead and run this and see what happens. The short answer is that nothing happens because I've defined a class, I've defined this method, but I haven't ever called it. I haven't ever told it to execute. So that's what we have to do here. Now, Visual Studio Code will do this next part for us automatically, so I'm going to show that in a moment. But first I'll show how to manually have these test cases execute, so that because you kind of need to know how to do it, I think, in my opinion, but also if you happen to be in an IDE that doesn't do this kind of stuff for you. So we've seen a similar line of code to this before, where we're going to check that dunder name variable. And what we're doing here is we're asking, are we really trying to directly run this file, or is this like an import or something like that? Because Python is going to have to process it and take a look at it either way. So we need to tell it, are we going to actually run here, or are we just accessing this information? And so we've used a block of code essentially like this, and then we define a main method, and we put all of our code that needs to run, like our script, in that main method. Unittest as a framework provides a main method as long as I call it with the unittest prefix. That will execute all of our tests for us. And so let's try running this again. And now we're in business. So the user interface does provide a little bit of information for us here. This dot represents a test that has passed, right? And I only have one test. So that one test passed, and I get this OK message at the bottom. Let's see what happens if we have a test that doesn't pass. So I'm going to, actually, I'll just add one on. Kind of copy that and paste in another one, and I'll say, let's say that I assert that 3 times 3 equals 10, and I'll run this again. So my test thrice method did not pass. Not all the assertions there passed, so I don't get a dot. And up above that, it's telling me where the error is. That, look, on line 15 here, excuse me, this assertion isn't true. 9 is not equal to 10, right? I told it to expect 10, and it actually returned 9. So we ran the one test, which a test is this method, right, with 2 assertions in it, and it failed. So that's the kind of the user interface that we get here. So that's how we can write code to run this suite of tests for us. As I mentioned, Visual Studio Code can do that for us, and it'll make it look a little prettier as well. So let me kind of clean this all up and take a look at the testing interface in Visual Studio. All right, to access the testing features in Visual Studio Code, I'm going to use my navigation bar over here on the left, and at the very bottom there should be a little, I guess it's like a beaker, kind of like a test tube, for testing features. Now, if you don't have that, it means one of a couple things. Maybe you haven't installed the Python extension stuff yet. Maybe it doesn't recognize that you have a test file within the files that you currently have open. So make sure you have that open first. But at that, you'll have to stop and fix that problem before you can kind of move on from here. Now, I've used the testing features here before, so it's going to look slightly different. But if I click on that, you're likely going to see. I'll see if I can get a screenshot to edit in here and show you. It's going to ask you if you want to configure your tests, or if you want to install a testing framework in the event that you don't have one, right, or don't have the one you want. So if you don't get that, or if you made the wrong selections there and you want to go back and change them, you can access that configuration by clicking on this little gear icon here, the manage button, and there's a command called a feature called the command palette, which pops up this almost like a little command line where I can type in what I want to get to here. And I've used it recently, so it's right there. But if you just type Python configure tests, the autocomplete will help you find it. And this should be what you see when you're configuring your testing environment here. So first, it's going to list all the frameworks that it recognizes for testing. I've got PyTest and unittest. You probably have the same two. As I've mentioned a couple times now, we're going to use unittest. So I'll click unittest. And then it's asking where should it look for testing files for these testing modules. And you can probably get away with like your whole root directory. If I do that, I probably have some other testing files that are just going to kind of clutter things up. So I'll select the module 7 folder, which is where I'm working currently. And last but not least, it wants to know the file convention that you're using for your testing modules. I'm using the standard one, which is test underscore and then wildcard, because it's going to be whatever module you're testing. So that's the second to last choice here. So I'll click that. And then after that, we should get a list in this testing pane here of all of the tests that it recognizes. All right. So again, you'll need to stop and fix it if you don't have it at that point. And I'll pause here for a moment. All right, so when I want to run my test, there are a couple different places I can do that. So you'll notice that there's a little green run button right next to my method here. I've only got one, so that's why that's the only one. If I had additional ones, I would get that as well. At the very top of my testing pane, I can run all the tests, and I can also expand this open and see. I can drill down and I can just run the individual tests I want, or all the tests for this module. So whatever I want to do, I'm going to click the run button. Notice there's also, you can run it in debug mode, and that's not part of the video we're going to talk about here. So I'm just going to run them. And I failed the test, right? I've got that test case that I added, that assertion that I've added that doesn't pass. And so it's giving me a little pop-up here. It's kind of busy on the screen, but it's giving me some user interface here where I can see that same error message that 9 is not equal to 10 on line 15. So it's kind of hard to see. I'm not sure I'm a big fan of the way Visual Studio does this always, but it does get your attention. And it keeps it at the top of the screen while you kind of scroll around, which is helpful. So let's go ahead and correct that. The correct expected result there is if I triple the number 3, I should get 9. And now I can, I guess maybe I should also point out some of the other user interface. I've got the test result window down here, and then I do get a little list of all the tests, and it indicates what's not passed. So you can kind of experiment with that and see how you like working with this. But I'll go ahead and now come back here and run all my tests again. And now I've got the pretty green check mark, and notice I like the older results get pushed to the bottom here. So my most current result is that my tests have all passed. Okay, so I'm in good shape. I'd like to add some functionality now to my simple functions module, and to do that, I'm going to take, I'm going to call it a test-driven approach. This isn't true test-driven development, which is a whole big thing. But I just want to reinforce that idea that it's really good. It's a really great habit to be thinking about testing your code before you even write it, which to most people sounds backwards, right? But the truth is, I can't write code to, for example, to multiply times, to thrice a number if I don't know how to do that myself. I mean, maybe I'm not good at the arithmetic, but I need to understand what this code is supposed to do. And writing the tests will help me make sure that I do understand that. So I'm going to define another test here. Test, and this one I'm going to test twice. So I've got a thrice method, and I'm going to end up developing the ability to double a number. to twice a number. That's not really a very good use of that grammatically, but I'm going to write a couple assertions here. And I'll just start with one assertion for now. And I'm going to say, oops, if I assert, I'm going to assert that if I double the number 2, my expected result is 4. That seems pretty reasonable there, right? So right away, if I, and in test-driven development, what you're supposed to do is write your test and then run it right away. And I'm going to run it, and I'm not even able to execute this test because I don't have it. The error is that this twice function doesn't exist. So that in test-driven development, if I were really doing it a full-on approach, I fail the test, and now I go write the minimal amount of code to get that test to pass. I won't be quite that strict about it here, but my point is I can run this, and the world doesn't end. I've got an error. A big thing about unit testing is that you have to accept that it doesn't always work right the first time. That's the way programming is, and I like unit testing in part because it reinforces that like your code isn't perfect the first time you write it. You gotta refine it. You gotta keep developing it. It's not a one-time thing. Programming is a process, and so I need to go over and develop this functionality. So I'm going to go to my simple functions, and I'm going to, oops, that was too much. I was going to make that a little bigger for the purposes of the recording. So twice number, and I'm going to make an intentional error here. I'm going to say, I'm going to accidentally type a plus symbol instead of the asterisk for multiplication. So I'm making a mistake. I'm going to go ahead and save that. And now let's go over here and run our tests again. My tests passed. And I know I've made a mistake. The idea here is that your tests are only as good as the thought you put into them, right? The big question I always get with test cases, like in my 100 level programming classes, when I ask students to just kind of write out test cases as code comments, is, well, how many test cases do I need? The sarcastic answer to that is, how long is a piece of string? I don't know. It's a question that can't be answered simply. It depends is the better answer. And what I think is the best answer is, it's up to you to decide. Because part of the point of this is for you to learn how to develop good testing strategies. One test case is usually not enough. How many is enough? I don't know, 100? 100 is probably overkill in a lot of cases. What I do know is that if I put a number on it, then students just grab onto that number and they think, well, if I say it needs 5 test cases, then they're going to write 5 test cases. It doesn't matter if 2 would have done the trick or if 10 are necessary to really test it thoroughly, they're going to write 5. So I hate answering the question, right? How many test cases do I need? I don't know. You need enough test cases to thoroughly test your code. In this case, 1 wasn't enough. And I'm using the word test case. I really should be saying assertions at this point. I've got 1 assertion for this test case, and it's not enough because it doesn't catch potential errors. If I say, let's assert equal that twice 3 is 6, now it's caught that there's an error, right? It's saying that, well, you said the answer should be 6, but I'm calculating 5. So the point here is that 1 test case usually doesn't do it. You have to think about, what test cases do I need? And there's some art to that, right? That's where a lot of your learning is going to take place, is figuring out what are the test cases I really need in order to effectively test this. If I'm doing a bunch of if statements, then we like to test edge cases or boundary cases, right? So if I'm writing code that is going to determine a letter grade based on somebody's percentage in class, then one of my test cases should be 79.9%. Does that return a B or a C, right? 80.0%, does that return a B or a C? Those are edge cases, right? Those are the boundaries between one result and another. We also, we want to have often those kind of edge cases or boundary cases. We also want to test for just unexpected or invalid values. Maybe not every one of them, but like in a, if I'm doing letter grades, what happens if I get a -1? I mean, presumably a 0 is an F, but is it possible to have negative points? Maybe it isn't. So maybe, but I need to test for that. Whatever, I don't know how I'm going to deal with it. That's for me to decide when I write the code, but I need to test for it. I need to decide what do I expect to happen if somebody gives me some value that doesn't make sense. And then I always like to say, so my test cases, I usually do a couple, like softballs, a couple ones that like I just usually, if it's a math thing, things that I can do in my head, right? So 2 and 3, those are pretty easy to do in my head. But then I also want to have some, maybe a big number. So assert equal twice 450. Okay, and that's going to be 900 if my feeble math skills are right. And it's always possible that I'm going to mess up even simple math because I'm not very good at arithmetic. And then some sort of unusual numbers. How about if I, what happens if I give it a float? So what if I give it 2.2? Whoops, I need to, I'm not writing my test case correctly here. Twice 2.2 should return 4.4. Okay, and at some point I'm just going to break down and start copying and pasting here. And what if how about a negative number? Does it work correctly if I give a negative number? So twice -4 is -8. So now I've got, again, you have to decide at what point is it enough. I'm not really sure, but I've got at least a little more thorough job of testing here. So I'm going to run that now. And again, I've got all kinds of mistakes because my code is broken. So let's go over now. Now that I've developed my tests, now let's go over and get it to pass those tests. So this is a pretty simple mistake, especially since I did it on purpose. Most of my mistakes aren't on purpose, and I make plenty of those, but this one was intentional. So now I'm going to run it, and there we go. I'm happy to see that all of my test cases, all of my assertions have passed. And I feel pretty confident that this method now is pretty good, is in good shape. If it were a more complex method, 5 test cases may very well not be enough. So you just have to take it case by case. You have to think about what your code needs to do and what situations will it encounter, and then decide how it should handle those. Okay, that's a pretty good example, of just some really basic testing. What I'd like to do now is shift to a situation that's maybe a little bit more complex. It's still going to be pretty basic, but a little more realistic in terms of kind of real world application of this. So let's switch over and take a look at that now. Okay, so this is a little more of a significant project or set of code that I've got open here. So, and this was just left over from a previous video I recorded on object-oriented programming. So this is a bank account, which keeps track of an account number, the name of the owner, and a balance, and some associated functionality like deposits and withdrawals. And then it uses inheritance. So there's a checking account, which is a type of bank account, and adds the ability to write a check and keep track of check numbers. And then there's a savings account, which is a bank account that adds an interest rate, the ability to add the interest every month or however often it runs onto the balance. So the details of that aren't particularly important for our purposes here. I do also notice that at the bottom of this, I have a bunch of testing code, and to be honest, as I look at this now in the context of testing, this is pretty weak. I do really what I make an account, I get the last check number. This has to do with where I was in the video, but this is not unusual for things that I see students do. When I tell them to test their code, they write like a couple lines and they call it good. That's the habit we're trying to break. That's the shift we're trying to get you to make in your perspective. So I have a better way of doing this stuff now with unit testing, so I'm going to just comment that out. And I don't think I'm going to need to make any edits to this code. I mean, this is a case where I've got the code already, and now I want to write tests for that. And in my opinion, that's a little bit backwards, but that's the situation I happen to be in here. For the purpose of this video, that's appropriate. I'm going to keep that file open though, because I don't remember all the method names and stuff that I'm going to have to refer to. Okay, so this is going to be my my test module for that, and I'll have to add my comment block later, so you don't have to watch me type all that. And we're going to start off by importing unit test. Okay, easy to forget these kind of details while we're working here. And then because I'm going to be testing the accounts module, I have to import that. And I guess I maybe skipped a step here or glossed over the naming again. So the module that I'm testing is called accounts. That means my test suite is called test_accounts. But I'm going to use a from statement again, because I don't like to fully qualify my from accounts, qualify my references here. I want to just be able to call them as if they're local. Again, not able to type and talk at the same time. From accounts imports everything. All right. So I've got this kind of set up and ready to go, I believe. And I need to create my my unit test class, right? My subclass, I guess I should say. I'm going to call this one test accounts. Unit test case. Oops. Test case. All right. So I'm back to where we were in our other example there, where I'm ready to kind of define my tests, right? Define each of these little assertions that I'm gonna be using. So, all right, where to begin here? So I'm gonna start with just a really basic, let's just test if we're able to create an instance of a bank account and get the balance. So I'm gonna call this test get balance. There is a method called get balance. I'm confident in that because that's the proper naming convention, and I'm assuming that I used it before. So self.assert equal. And where I'm now right away, I'm going to run into a new problem, which is that, well, this is now an object-oriented setting. I need to have an instance of the bank account class or one of the subclasses to be able to interact with here and see if it works. Again, here's one of those cases where clever and experienced Python programmers are going to come up with this really crazy looking one line of code that does this. And I'm going to intentionally not do that, because what I want to show is that inside this method, I can write other code. I could have print statements if I want. I think that would be a bad idea, but I can do that kind of stuff. I'm going to make an account object here, equals, and this will be just a generic bank account. And it's the user interface is helping me out here. I need to provide an account number, 1, 2, 3, 4, 5, 6, an owner's name, Abraham Lincoln, and that's it. I think I just need to provide those two things for the constructor. So now when it runs this test case, when I run my test cases, it's going to create this object, and now I can use that for my assertions. So account1.get balance. And if I just create an account and don't do anything else, then I'm going to assert that the balance should return 0.0. So let's see if that how that works. Let's see if everything is even being recognized. So it's kind of subtle up here because I've got so much open, but it has now added another node here for my test accounts. And so I can minimize this. And this is maybe a good place to show that there is a way to filter these, especially if you open a root folder and you have all kinds of test methods showing there, a whole bunch of different test cases. I can filter this and say, well, show the active file only. And now it'll only show for the file that I've got, that I'm looking at. And that's convenient for me at the moment, I think. But I can always turn that off if I want to see them all. And then I can just expand the ones that I need. Okay, so I'm going to go ahead and run these. And it works. I asserted that it would return 0, and it did. Here's another case where that's not the most robust. That's not the most robust test, but it does work. I think to get into more interesting stuff, we're going to need to check things like, can we deposit money into it and things like that. So what this leads to is that I'm going to need one or more bank account objects to run all of these tests. And so I don't want to have to I have all of these methods I have to test. Okay. And that means I'm going to have to make an account 1, account 2, all these things for all those tests. Unit test gives us the ability to run that kind of code once before we start doing all of our tests, and have those things available to us throughout. So if I define a method called setup, and this is always interesting to me because the Pythonic way of naming this, it should really be set up. But I suppose there's some historical reason from the early days of the unit test framework that it is called set up in the way that I would name a Java method. So I can now move this line of code out of there and put it there. And now I should be able to run. Oops, I didn't mean to run it that way. I should be able to come over here and run my tests again. And I've got some kind of an error here. What do I have? Account 1 is not defined. So I've done something wrong with my setup. Oh, I've made a dumb error. So I guess I won't edit this out because this is an error that you're going to make too. Setup is an instance method, and account 1 needs to be an instance variable. So that was a silly mistake. Self.account1. I guess it's good that I made that mistake. If I were smarter, I would have done that on purpose. This was an accident because I'm just forgetful. So now every time I refer to that, it needs to be self dot. And this is an object-oriented thing. So another case where if you don't know a lot about object-oriented programming, you probably want to go and brush up on that. You can also just kind of copy what I'm doing for now, and that should get you through. But things that we create that we want to use throughout all of our testing need to be instance variables. So self.account1. Otherwise, it's scoped just to that variable, and I can't access it from down here. So there you go. I think now that should fix it. Okay, there we go. That one had me worried for a little bit. And as long as I'm here, I might as well, let's make another one. I'm going to make an account 2. This one's going to be a savings account. Savings account, and so I need to provide now an account number that should be different from the first account number. It's going to have a different owner. And for a savings account, I do need to provide one more piece of information. It's the rate, or the interest rate. And so I'm going to, this is going to be 1.25% interest rate. I have no idea I do have some idea, but the current real life interest rates don't matter to us. I want intentionally kind of an odd number for our purposes today. 1.25%, and this is just a little math thing in case you've forgotten from when you were younger. A percentage, when we convert it into a decimal, we got to scoot that decimal over a couple. So 1.25 becomes 0.0125, essentially divide it by 100. So that's my purpose there. And I guess my savings account, a savings account with zero is not going to be very useful because if I try and calculate interest on zero, it's just going to be zero. So I'm going to call the deposit method, and I'm going to put $100 in there. Okay. So now my get balance method, I should also check that it works for account 2. So self dot assert equal self dot account 2. And in this case, it should return 100.0. So again, I'm going to come over here and run my test. So far, so good. Okay. It turns out that this actually is also testing the deposit method, and honestly, that might not be that's not necessarily the best design. The best possible design for your unit tests are that they have no dependencies. This is kind of an internal dependency. I can't really avoid that. So I'm going to deposit $100, and that seems to work. All right. The get balance method now is tested at least on a basic level. The only additional way I could test this would be to make more accounts and keep getting those balances, or to do other transactions. And so I can maybe circle back to that later, but this video is already getting longer than you probably want it to be. So let's go ahead and test the add interest method. So this is for a savings account. What it does is it's going to calculate what the interest is, and it's also going to add that to the balance, and it's going to return what that interest amount was. So assert equal okay. Now, what should this return if I add the interest for this? I had my number blocked. I forgot what I was looking at. We have $100. So this is not a coincidence that I chose these numbers. $100 and 1.25 interest. That's math that even I can do. That is $1.25. And I should maybe we should look at the code really quickly for this. What the interest does is it calculates what the interest is, which is just multiplying the balance times the rate. And then it's going to increase the balance by that much, right? And then it's going to return that interest amount, so that if I need to check how much I got, I can do that. It sort of does two things. It adds onto the balance, and it returns the amount that it did add onto the balance. So I can also assert getting the balance here. I can get the balance, and now it shouldn't be $100 anymore. It should be 101.25. And this is important that I do both of those, because I just said that the add interest method does two different things. So I need to test both of those. All right, let's go ahead and save that and run it. And we're doing well. So that method seems to work again. It seems to work in both ways. Let's try it one more time, because again, one test is probably not enough. And now the numbers are going to get a little trickier, right? Because I'm going to add on to the balance. Well, now I'm not going from $100. Now I'm starting with $101 and 25 cents. And you see me opening the calculator, because now we're in math that I can't do in my head. So now the math is going to be 101.25 times 0.0125. So that's going to now be $1.27 basically. Okay, so $1.27. And when I get that balance again, I need to check both. I need to test both of those. Now it's going to be 101.25 plus $1.27. So 101.25 plus 127, $102.52. All right. So I'll go ahead and save that. And so again, I want to make sure I wasn't paying attention as I was doing that, and I overwrote one of my other assertions there. So I got to put that back where I got the balance, and I asserted that it was 101.25. Sorry about that. I'm getting clumsy as I work. Okay, so now I've got 4 assertions here. I'm going to add the interest, then I'm going to check the balance. I'm going to add interest again, which is going to be a different amount, and I'm going to check the balance now, and it should be $102.52. Pretty straightforward. I've got some problems. So what this comes down to is that my assertion error here, this first assertion error, I said it was going to be $1.27. It actually came back 1.265625, right? Well, that's $1.27. It really is the same thing. This is a rounding thing. This actually, as a side note, brings up something that I forgot today, but whenever I'm dealing with money on a video, I always like to point out that I'm using float data type, which is kind of the built-in data type to handle numbers that have decimal places in Python. You absolutely should not use float data types when you're dealing with money in the real world, because floating point rounding is going to cause you a problem. And it's no big deal in this little video that I'm recording, but if we're really talking about somebody's money, then rounding errors are a problem. And I encourage you, if you're curious about this on a technical level, to Google it. Use float for money or something like that, and you'll see people. It's a very nuanced reason, and it's an interesting one if you're curious about the way computers handle numbers on a really basic level. It's not because of this issue that I'm running into. The issue that I'm running into is that I've just rounded, because I know that when we talk about currency, we only round to 2 places. The computer doesn't know that. Python doesn't want to throw away that data. It gets everything. So I need to have a way to test this and still have it work. The way that we do that is, instead of using assert equals, or equal, excuse me, there's one called assert almost equal. Okay? And so it's saying it is for this exact kind of situation where what if we don't want it to, we don't care if it's exactly the right number, it just needs to be really close to that number. I keep wanting to go run it up there just out of habit, but I need to run my tests here, and let's see what that does. It still doesn't work, and I'm still getting the same kind of error. It's giving me a little more information. It says within 7 places. So the default behavior of assert almost equal is to check to 7 places after the decimal. That's way more than I need. I want to check to 2 places. So there's an optional argument I can add on here. So I'm going to say places equals 2. All right, and I just happen to know that because I've used this function before, but I can add on to this and say how many decimals I care about, how many decimal places I care about. So let's try it one more time, and I think we're going to be in better shape here. So I did fail, but I didn't fail on the same test, on the same assertion, excuse me. I failed on the next one down, which has the same problem, right? It says, I said it was going to be $102.52. It was 102.515625, right? Same kind of thing. So I'm going to change this to an almost equal, and then say places equals 2 again. Save that. Run my test again. And I am back in business. So that corrected that little rounding issue. We're going to wrap this up here. Now, unit testing is a really big topic. Software testing in general is, and test-driven development. All of those things, that could be a class all by itself, a course all by itself. We don't have time to cover all of that here. What we want is we want you to understand what unit testing is, and I want you to have a basic ability to implement this so that you can start using this in your software development workflow and in the projects that you do for class and in the stuff you do outside of class. You should be now developing test cases. The unit test framework, you can get a good sense of what's possible just through the kind of the auto completion here in Visual Studio Code, you can see all these different ways to have assertions. If I want to test if something is greater than equal, is or is not, in, like if something is in a list or whatever. There are all kinds of these assertions here, and just try them. See what they do. The worst thing that happens is that your test doesn't pass, and you can fix it or correct it or delete it if it ends up not being something you can figure out. And of course, there's all kinds of documentation online and a lot of great videos out there. But I think this is a good place for us to wrap up so that now you can get started on trying this on your own and seeing how it works. So as always, reach out if you have any questions.